You have fallen into Event Horizon with John Michael Godier. In today's episode, John is joined by Professor Avi Loeb. Avi Loeb is the Frank B. Bird Junior Professor of Science at Harvard University, Chair of Harvard's Department of Astronomy, Founding Director of Harvard's Black Hole Initiative, and Director of the Institute for Theory and Computation within the Harvard-Smithsonian Center for Astrophysics. He also chairs the Advisory Committee for the Breakthrough Starshot Initiative, serves as the Science Theory Director for all initiatives of the Breakthrough Prize Foundation, as well as Chair of the Board on Physics and Astronomy of the National Academies. He is the author of 4 books and over 700 scientific papers. He is an elected Fellow of the American Academy of Arts and Sciences, the American Physical Society, and the International Academy of Astronautics. In 2012, Time selected Loeb as one of the 25 most influential people in space.
Dr. Loeb, now we were discussing the Vera Rubin Observatory, which is one of the most exciting scientific instruments coming along in the near future, which I believe it sees first light and they start calibrating it inside of a year. Now, once we have that, we are going to be able to do all sky surveys regularly with this instrument, which is uniquely suited for it, and look for things like Planet 9 and maybe flashes from primordial black holes and things like that, but also further interstellar objects, including things like Oumuamua. Now, the very strange thing about Oumuamua that isn't mentioned enough, and this is why I'm mentioning it, because it isn't talked about enough, is that that object was spotted the very first moment we could technologically see it with pan-stars. We weren't able to really see these things before this, but we saw it the very first moment we could, which means that whatever its nature is, it must be part, or suggests it must be part of a statistical population of like objects. We should see Oumuamuas cooking through, and I believe one of your papers went into this, at least once a year, something on those lines, maybe even a little bit sooner than that. But I really don't think we're going to see an object like that. We don't see these in the solar system to this extreme geometry. We don't see with other interstellar objects like Borisov, it looked like a comet. Oumuamua remains unique, and I think it's probably going to survive that and remain unique after several years of operation of Vera Rubin. Shoot me down.
Well, no, in fact, we would expect to see one every few months. And if we don't see it, then it would make Oumuamua even weirder. It was weird in many respects because most of the interstellar objects are expected to be removed from the outer parts of planetary systems, like the Oort cloud, where you have icy objects that have water ice on their surface. So if they were to arrive close to the sun, they would appear as comets. And indeed, we noticed the Borisov a couple of years after Oumuamua, and that is what we expect. It looked just like a comet from the solar system. But Oumuamua did not show any sign of evaporation. Nevertheless, it was pushed away from the sun. Also, it had an extreme geometry. It was most likely flat, and the amount of sunlight reflected from it changed by a factor of 10 as it was tumbling every 8 hours. So it looked like a very weird object that we've never witnessed before in the solar system. In fact, 2 years later, there was another weird object. It was pushed away from the sun by reflecting sunlight without any cometary evaporation. It ended up being a rocket booster that NASA launched in 1966. It was discovered by the same telescope in Hawaii, Pan-STARRS. And so it's possible that Oumuamua was space trash, a technological relic, and that's what I suggested and discussed in several publications. But my colleagues argue, no, it's probably a rock of a type that we've never seen before. A hydrogen iceberg, a nitrogen iceberg, some unusual water iceberg. What we need to do is find more of the same, if that's the case. And if we don't, it would make Oumuamua weird in yet another way. And of course, the fact that we saw a familiar comet after Oumuamua does not make Oumuamua familiar. I mean, it's just like walking in the street and you see a weird person, and after that you see a normal person. It doesn't make the weird person normal. And the nice thing about the Rubin Observatory is that it will have a camera with 3.2 gigapixels, 1,000 times more pixels than your cell phone camera, roughly half the size of a person, that will monitor the southern sky every 4 days. And by the way, in addition to interstellar objects like Oumuamua, the data from it could reveal unidentified anomalous phenomena, UAPs. And I'm planning with my postdocs to search for both objects like Oumuamua or UAPs. Because right now, we built an observatory at Harvard University, monitoring the sky 24/7 with much less resolution and sensitivity than the Rubin Observatory, but we already observed 500,000 objects over 5 months. And just a few days ago, we posted publicly the first commissioning data, the analysis of the first results from this observatory. We are trying to identify the nature of the objects that we see in the sky and check whether they are familiar or not familiar. Are they leaves, insects, birds, clouds, balloons, airplanes, drones, satellites? And in the paper, we discuss how we apply machine learning software to figure out what the objects are. And this is just the beginning, the commissioning data. We are now in the process of building a second observatory in Pennsylvania, and we will start very soon constructing a third observatory. And altogether, we are expecting to triple the data rate by summer of 2025. And moreover, we will use multiple units for each observatory. In other words, these would be separated by a few miles, and we could do triangulation. Because the reason that we have two eyes is that it was useful for survival. We could gauge the distance of a predator as an existential threat. So obviously animals that had two eyes survived much better than those with one eye, because those with one eye could not assess the distance of a threat and could not protect themselves as well. Now, if we have multiple units looking at the same object, we could figure out the distance, we could figure out the actual velocity by which it's moving, the acceleration, and that's what we hope to do next in the coming weeks. And altogether, we are bringing scientific rigor to this subject. I mean, there were lots of reports from military personnel of unusual objects over the years, hundreds of them. And the Director of National Intelligence submitted 3 reports to Congress about them, stating that their nature is not understood. And then there was a new office established under the Pentagon and the Director of National Intelligence called the All Domain Anomaly Resolution Office to look into past reports. And in the first year of their analysis, they claimed that 97% of those reports that they looked into can be explained away as mundane objects. As it turns out, just recently, this week, there was a new report, the latest annual report from AERO, the All Domain Anomaly Resolution Office. And in that report, they discuss a significant fraction, about half of the objects that they looked into that were not drones, half of them are unexplained. And the director of AERO, the new director of AERO, stated explicitly that some of these objects cannot easily be understood based on what we know about engineering of human-made technological objects. And so the fundamental question is, are we being visited? To address that, we really need high-quality scientific data. Now, of course, what is happening is also that there is a push from Congress to ask the Department of Defense to release more data. So, we can chase government officials and pressure them to tell us what they know or don't know. And that, of course, may lead to something or not, but there is a better path forward. And that is what the Galileo Project observatories are doing under my leadership, and that is to study the sky, scientifically speaking, and figure out, because the sky is not classified and we can search the oceans as well. And rather than rely on hearsay testimonies about classified information, the way we heard at the latest congressional hearing on UAPs, we can just collect data from sensors that monitor the sky and release the data openly to the public. That's what the Galileo Project is doing. And my point is, the standard scientific practice is far more informative than political maneuvers aimed to disclose classified information from stubborn government agencies. The government is focused on national security. Anything that came from outside the solar system has nothing to do with national security, and that defines my day job and expertise as an astrophysicist, to figure out what lies outside the solar system. And so we can imagine, even the revelation that there was, for example, there are programs for retrieval of relics from crash sites or imaging of UAP. One would imagine that all major nations would have programs of this type. And the purpose is to learn about technologies that were developed by adversarial nations. Of course, that can be accompanied by reverse engineering efforts to reproduce these technologies. And there might also be biologics in crash sites if the equipment carried pilots. But the fundamental question is whether some of the data collected by these programs indicates an extraterrestrial technological origin. If such data exists, I would love to see it. We haven't seen it. We just saw testimonies from people who claim that there are programs of this nature. I will be delighted to help the Department of Defense or the intelligence agencies figure out what extraterrestrial origin may mean and what these objects might be if they have it. And the reason is simple. That's my day job as an astrophysicist.
Is there any chance, Dr. Loeb, of the Galileo Project eventually saying, okay, well, does anybody have any materials that you want us to look at? And things like that, associated materials with UAP. Is there any possibility of going in that direction and saying, does anybody have anything privately?
Yeah, I would love to have access to such materials if I know where the material came from. And then it's very easy to tell if the material originated from outside the solar system. That's what we did with the materials that we retrieved from the crash site of the first interstellar meteor in the Pacific Ocean. We brought those materials to a laboratory where we analyzed their composition. And if we have a few grams of those materials, we could infer the age. We can date the age of the material from radioactive isotopes. We know precisely the age of the material that made the solar system 4.6 billion years ago. And if we find an age that is different than that, that would be indicative that this material came from outside the solar system. So if anyone has materials, we could immediately verify based on isotopes. It will take some time to do the analysis. It took us a year to publish a very extensive paper analysis of the materials we retrieved in the Pacific Ocean a year ago. And it was peer-reviewed and published. And of course, during that process, there was a whole community of people on loudspeakers saying, we went to the wrong place, we found coal ash, you cannot trust the US government. These are people who claim they're trying to protect science. They're pretending to do that, but they're actually anti-science. Because the only way to gain new knowledge in science is, first of all, to pay attention to anomalies, not to say that Oumuamua is a rock of a type that we've never seen before, but leave on the table the possibility that it might be artificial in origin. Or if you see an interstellar meteor, data from the US government that was verified by the US Space Command, not to dismiss the data by saying, I don't believe the US government. That's not a sound scientific reasoning. Nevertheless, there were several papers that were saying that and got published. And then also when people put the time to go to the Pacific Ocean, collect materials, should have at least some respect and wait until they publish their results before criticizing the possibilities that might come out of the analysis. And the analysis was done by my colleague, Professor Stein Jacobson, one of the world leaders in geochemistry, with the very best instruments that the world has to offer. We also had some analysis at the Bruker Corporation in Berlin and some additional analysis at UC Berkeley. So we are really following the scientific method of putting effort and funds towards collecting evidence, either through the Galileo Project observatories or expeditions. That's a lot of work. It's much easier to sit on your chair and criticize and raise doubts and issues. And many of those critics, they are not really accomplished scientists. They are not necessarily people who worked in this field before. And it's clear that they want to gain some visibility by attacking this research, which the public is very interested in. But I simply ignore them and I follow the scientific method because life is short. And why should I waste time on invalid criticism? I better collect more evidence and eventually the truth will come out. Once the evidence is clear, if we recover, for example, if we go back to the Pacific Ocean as we are planning in summer 2025, and now we will use a robot, a remotely operated vehicle with a video feed, and we will look for bigger pieces. Suppose we find the core of the object, and suppose it looks like a real technological object and not a rock. Then there would be no doubt, and we can demonstrate if it's a big chunk of mass, we can demonstrate that the isotope abundances indicate an age that cannot be related to the solar system. We can figure out, in fact, the distribution of elements to be different than the solar system materials. So there are lots of ways to show that it didn't come from the solar system. And suppose we do that, and I think that there would be no way for other people to argue that it was manufactured by humans. Suppose we detect UAPs that behave in ways that human technologies cannot reproduce. The way that the new director of the Aero was talking about, eventually there would be no way out. So my wish is really to find as much data as possible, to basically flood the literature with scientific data that leaves no doubt that we are looking at something new. And the wish of the critics is to say, no, we don't want to. First of all, we will doubt any data that comes from some directions, and we don't want to see anything else. And, it was reflected in a very simple statement made by a colleague of mine who worked on rocks in the solar system for decades. When he attended a talk about Oumuamua, and we left the room afterwards, he told me, Oumuamua is so weird, I wish it never existed. And when you think about it, it's really the wish of those critics that the data did not exist, that no anomaly exists, because then they can subscribe to traditional views. Nothing is new, everything is boring, and they would maintain their stature, and there is nothing but rocks in the sky. But the truth may be different, and the way to arrive at the truth is not to be deterred by those narrow-minded people who are not willing to learn something new.
That bias is actually even worse than that in a lot of ways, because I can sit here on the internet, and I've done this for a better part of 9 years now, and talk about things like conceptual ideas like von Neumann probes, and how you could have self-replicating probes basically populate the galaxy in just a few million years at sublight speeds. And if one of those happened to be a 3D printer and it printed out a UAP that's doing an atmospheric study on Earth and somebody saw it, well, there's your UFO. Well, that means it's not implausible. But if you put it in terms of the von Neumann probe, it gets a lot less flack than if you put it in terms of the UFO. And it just seems that the closer to Earth you get with the technosignature, the less people are going to associate it with science and more with more wild claims about UFOs. But the end result is I can't tell you what the difference between a von Neumann probe orbit of Saturn and one in Earth's atmosphere is. They're the same thing.
Well, it's clear. One thing we should keep in mind is that what we find in the sky is a mixed bag. There are lots of balloons, there are lots of human-made objects. And maybe the intelligence agencies will be happy with identifying 97% of the objects. But for me as a scientist, even if 1 in 1 million or 1 in 1 billion objects in the sky is of extraterrestrial origin, that would be the biggest news that science delivered to humanity. Therefore, we should study those objects in meticulous details with the best instruments we have. And the only way to do that is through hard work. It's not a matter of an opinion, and it's very easy for someone to have an opinion, either to be a believer or a skeptic. In politics, you see that very often, and that's why we have polarization. You have tribes of people belonging to one extreme or the other, and very few are in the middle. And by the way, that's the reason that social media or AI are difficult to train on what is most reasonable, which is the middle. You can easily, there is much more training data on the extremes. And so if you were to train an AI system on what's available, it will very often go to one of the extremes because that's where most of the data is. That's what humans do all the time. But in matters of science, there is an arbitrator, and that is evidence collected by instruments that don't have an agenda, do not have wishful thinking. These are instruments recording whatever comes their way. There is a good reason why physicists use instruments. We cannot rely on eyewitness testimonies because when a group of people witnesses the same event, say a car crash, you will get different reports, even though it was the same event. That's why FIFA, the soccer world organization, is using cameras to decide whether there was a goal or not. They're not going around asking the players or the audience, what did you think about it? That's not a reliable way to get at the truth. And my point is that, if we invest enough funding in instruments that will give us the best data possible and we monitor our sky, we will eventually figure out if there are UAPs out there, and we will figure out their nature. And it's just a matter of time. And it's a waste of time to go after stubborn government agencies that may have some data but are not willing to release it. It's a bit childish to say, okay, let's put all our effort in dealing with humans rather than let's invest, millions of dollars or maybe billions of dollars in just instruments, the way science is done, and figure out the answer ourselves. Why do we need the government to tell us the truth about the interstellar space?
In regards to, science in this regard and data collection, it only takes one, it only takes one white crow to know that white crows exist, as someone once said. And all you need is one.
Yes, it's just like getting married. You just need one.
Some people may differ on that. But anyway, results of the Galileo Project. This first data release. Anything interesting? Anything that you said, that warrants further study?
Yeah, so there are a bunch of objects that we just don't have good enough data on. And partly it's because we don't have distance measurements. And to do that, we are hoping in the coming weeks to have multiple units observing the sky at the same time and separated by a few miles so that we can do triangulation and figure out the distance, velocity, acceleration of objects. That by itself would allow us to identify truly anomalous objects. So stay tuned. This was just the first paper showing that we can do this. And by the way, I should say, shortly after we posted the paper on the archive, where astrophysics papers are being posted, I got an email from a brilliant astrophysicist who said, this is an amazing paper, has such high quality analysis and work. I mean, it's clear that you put a lot of time and effort into this work. Is it possible for me to contribute? I can bring my own drones and we can use them to test your distance assessment and to test your instruments. And that was the greatest compliment that the Galileo team could have gotten, because it basically demonstrates this person read the paper and appreciates the quality of the work. And it's very different from those who would put on Instagram or TikTok a short video that makes derogatory statements about the work being done in searching for unidentified objects or going to the Pacific Ocean to look for materials from an interstellar meteor. Those people are really anti-science. They're not trying to collect evidence. They're just trying to get visibility by attacking the work of science.
Now, it has to be said here that what the Galileo Project has released is data. It's hard data. Null result is just as good as a positive result. It just helps you constrain things down. And the fact is, this is hard data. So the project is producing. And I'm looking forward to much more, because what'll be interesting is if you see something really anomalous.
Exactly.
However, there was one other occurrence in this that I wanted to ask you about. The detection of a meteorite falling over the Northeast. What came of that?
Well, there was a very loud signal in the audio sensors that we detected, and it could have been related to a meteor, but we just didn't detect it in our cameras, so we didn't mention it in this commissioning paper. I should say that I keep asking my Galileo Project team, research team, to tell me if they see an truly anomalous object. And if we find a truly anomalous object, we will dedicate a full paper just to this object. What we did in this commissioning paper is discuss a population of 500,000 objects, because it's the first time we put out data. And we will also release the software that we are using with machine learning, state-of-the-art software, to analyze the data so that anyone can reproduce our analysis if they want to. And altogether, it's a very different and maybe refreshing approach to dealing with UAPs, because the other side of the coin is that the government is hiding the most interesting data based on the congressional hearing that we heard. They must have a lot of footage, even from satellites, of UAPs. One day before I went to Torun, Poland, in celebration of Copernicus' birthday, and I spoke about the next Copernican revolution, one day before that, I was at the Munich Security Conference. It was the first time they invited an astrophysicist. This is one of the most important political gathering of heads of states and so forth. And when I looked at the roof of the hotel where the Munich Security Conference took place, I saw snipers with black head covers. And they were not there to protect me. They were there to protect the dignitaries like Kamala Harris that was there. And at that point, I realized that being an astrophysicist is a much safer job than being a politician. Nobody is attempting to kill me. And at the same time, it's such a great pleasure to learn about the universe, whereas in politics, the news of yesterday can wrap a fish in the market today.
True. And I often wonder if there, well, I won't get into it, but I will get into the idea of the congressional hearings. Now, I have to point out here first that what do humans do? And we often, when we try to envision aliens, we're like, well, what do we do that they could be doing, like radio and things like that? But the fact of the matter is that as a civilization, we have crashed disks intentionally on Mars, which were the back shells of the rovers and other craft that we've sent there. And we sent out interstellar objects, Voyager 2 and Pioneer, and I guess New Horizons. And one of them contained Clyde Tombaugh's ashes, who discovered Pluto. Good luck figuring that out, aliens. And then another one contained nude pictures of humans. And the third was a record containing Chuck Berry songs. So we do some very strange things, both interstellar and interplanetary.
Right.
Yet we don't expect aliens to do that as well. That just seems, again, another bias. What are your views on that?
Yeah, I completely agree. Those people who suggest that we are unique and special would argue that there was nothing like us before. And it's sort of like a person who stands at home and argues really at the center of the universe. And there is no reason for me to check if I have neighbors because it's an extraordinary claim. But I say, well, one day you might be surprised because someone will knock on your door. Of course, that may be a rare event. And if you want to know about the possibility of that happening, you really want to look through your windows, use a telescope if possible, or leave your home and go into the neighborhood. That takes a long time for us to leave the solar system, go into interstellar space. It will take Voyager, Pioneer, New Horizons tens of thousands of years to leave the outskirts of the Oort cloud. But another approach is to search for objects that made it the other way, objects that came from our neighbors to us. And that's the approach of the Galileo Project. And the reason I started looking in this direction is because of the weirdness of Oumuamua and also the interstellar meteor. That meteor was moving faster than 95% of the stars outside the solar system. It was also of a very unusual material strength because it disintegrated only in the lower atmosphere. Just for comparison, there was another meteor over Portugal and Spain that exploded in April 2024 at an altitude of 70 kilometers, whereas the interstellar meteor exploded at 20 kilometers. And the difference in the air density between those altitudes is a factor of 1,000. So the interstellar meteor was 1,000 times tougher. They were moving roughly at the same speed. It was 1,000 times tougher than the one that exploded over Spain and Portugal this year. And the question is why? And obviously, if we imagine that Elon Musk was not necessarily the most accomplished space entrepreneur since the Big Bang 13.8 billion years ago, you might have analogs of the Tesla Roadster car floating in interstellar space. In fact, Elon's Tesla car was calculated to perhaps collide with Earth in 20 million years. And if it does, and I can imagine astronomers looking at this meteor, they would say, if they are not aware that it was Musk's car, they would argue it's a rock of a type that we've never seen before. But if there was a scientist that is curious enough that would go to the meteor crash site, they might find evidence for metal pieces that indicate that it was, in fact, a technological product. So that's the scientist that I'm trying to be. And my hope is that during my lifetime, I will find evidence that we are not alone. And of course, that would have important implications for keeping ourselves modest, maybe changing our focus, coming together as a species, instead of fighting each other, trying to kill each other, and fighting on limited resources, territories on this rock that was left over from the formation of the sun. We would realize that we are all in the same boat, the Earth, floating through space, and there is a neighbor out there. And perhaps that neighbor would inspire us to work together and do better in the future than we did in the past. I think that there is an opportunity for us to have better role models than our politicians. And these would be messengers from other stars. In a way, it will be a new version of the messianic message that many religions talked about, where the Messiah will bring peace and prosperity to earth. I just have a variant on that scenario, and in which the Messiah will come from another star.
I tend to think of it in terms of exomusks. In other words, alien civilizations full of billionaires launching their vehicles into space, eventually launch enough to where it becomes a Dyson swarm and starts glowing in infrared and becomes visible to things like the James Webb Space Telescope. One last question. Interstellar meteors and the Galileo Project observatories, are they equipped to look for falling meteors of moving a little bit too fast? I mean, do you also look for that?
Yeah, definitely. And in fact, the Rubin Observatory will be an excellent survey telescope to look for that as well. And we are developing the software to analyze Rubin data in the coming years. So my hope is that we will be flooded with interesting data, and a few years from now, there will be no doubt that we have unusual things happening near Earth. And there is a good reason why many people in the public find it a fascinating possibility, because, we are all in the gutter, but some of us are looking at the stars, the way that Oscar Wilde pointed out. We are all familiar with the depressing news from Earth. If you watch the news, you often get depressed because it's all about a group of people trying to humiliate or fight other people on limited resources. It's a zero-sum game very often. But if we look up into the sky, there is an opportunity for an infinite-sum game where everyone will benefit. There is much more real estate in outer space than we find here on Earth. It's an uplifting message to just imagine that we can learn something new from a smarter kid in our block. And that's why a lot of people are looking for this uplifting news, and they are really interested in that. And I think it's just entirely inappropriate for the scientific or academic community to suppress that interest. In fact, we should promote it. We should use the best instrumentation we have at our disposal to address this curiosity that the public has. And I don't see myself as different from the public. I just see myself as a member of the public that was fortunate enough to be given the opportunity to collect that data and answer the questions that we are all curious about, rather than pretend to be the adult in the room. Many of my colleagues pretend to be the adult in the room. And I always say to young students and postdocs, never do that. Maintain your childhood curiosity, because that's the only way for us to learn something new.
I think if you're interested in UFOs out in the audience, or you're a skeptic of them, doesn't matter. The best possible thing that can happen that will demystify this, don't look to the government, as Dr. Loeb says, just become awash in data that you can look at, data that you can analyze. And that's what Dr. Loeb's doing. And Dr. Loeb, I wish you many, many decades more of this, and I cannot wait to just see what you find. And if something really anomalous happens, then it gets really interesting, does it not?
Yeah, thank you so much. I should say that it also gives inspiration to artists. In fact, I was contacted by two sculptors that produced sculptures, one of them of Galileo Galilei, another one of the search for objects like Oumuamua, and they will deliver them in the coming months to my office. These are amazing sculptures that I hope to share with the world once I get them. There is also a documentary by Netflix that hopefully will come out in a year, towards the end of 2025, that includes footage from the expedition that I led to the Pacific Ocean and the work of the Galileo Project. And I'm also, as of today, I'm signing a contract on a book with MIT Press that will hopefully allow me to summarize the amazing experience of collecting materials, collecting data, and doing this scientific analysis of that in the way that, science should be done by curious scientists that do not know the answer in advance and that maintain their childhood curiosity.
Thank you, Dr. Loeb, and I look forward to next time.
Same here.
Event Horizon and my channel are now available as a podcast on Apple Podcasts, Spotify, and YouTube memberships. Early ad-free episodes, bonus episodes, and sleep-focused content. Sign up now by clicking the links below to your platform of choice.